So in this video we're going to look at finding an iterated integral, or in other words an integral of an integral. So here I have the integral from 1 to x plus 1 and 2 to 4 of xy dy dx. So what I want to recognize first is I'm integrating first with respect to y and then second with respect to dx. So there's a sense in which we can rewrite this integral as the integral from 2 to 4. I'm going to leave a little space on purpose, and then from 1 to x plus 1. And what I want to recognize, this is really saying, because we're integrating with respect to y first, this is really y equal 1 to y equal x plus 4, and then we're integrating lastly with respect to x, so this is running from x equal 2 to x equals 4. And when you integrate with respect to y, the x is held constant, so the x can really be factored out of this first integral, and it's just the integral of y dy. And so we're integrating this guy first, and then once this guy's integrated, we then integrate with respect to x. So I also want to recognize that the region over which I'm integrating is a region in the xy plane. So these bounds of integration that we see here are describing a region in the xy plane. And in fact, we could draw it. I have the xy plane. This first one says go from y equal 1 to y equal x plus 1. So y equal 1 would be a horizontal line, and y equal x plus 1 would be the y equal x shifted up one space. So slope 1 going off like this. This is y equals x plus 1. And then this says integrate from x equals 2 to x equals 4. So 2 is going to be somewhere on the x-axis, followed by a 4. So that establishes vertical lines like this. And so we're actually integrating over the region right here. This is the region over which we're integrating. So it's at y equal 1, y equal x plus 1, the equation x equal 2, and x equal 4. This is the region of integration. And we could actually plug in 2 and 4 and get ordered pairs here. So this would be the ordered pair 2 comma 1, 4 comma 1 right here. 2 plus 1 would be input 2, output 3, and right here would be input 4. This is the point input 4, output 5, because it's on the line x plus 1. So we're integrating the equation xy over a very specific region in the xy plane. So we integrate first with respect to y. So integrating y with respect to y, I'm going to get the integral from 2 to 4. X is being held constant. Integrate the y. The antiderivative of y is going to be 1/2 y squared, and it's a definite integral running from y equal 1 to y equal x plus 1. So running from 1 to x plus 1. And then I have it integrated with respect to x first, so it still has the dx. And 1/2 is a constant, which can be pulled all the way out front. And then we do what we usually do. So here's 1/2 the integral from 2 to 4 of x times, we plug the upper limit of integration in for the y. So we're going to get x plus 1 quantity squared minus plug the lower bound of integration into the y, so we get 1 squared, and we haven't integrated with respect to x yet. And then it's just a matter of simplifying this. This is the antiderivative of 1/2 from 2 to 4 of x times, square the stuff out here, you're going to get x squared plus 2x plus 1, we're minus a 1, and this is still a dx. The 1 minus 1 will cancel, and we can distribute the x in. We get x cubed plus 2x squared, so we get x cubed in parentheses x cubed plus 2 x squared, and this is the dx. I'll bring it over here. And now this is just an integral with respect to x, a standard single variable integral. Go ahead and integrate it. So the antiderivative of x cubed is going to be 1/4 x to the 4th plus the antiderivative of 2x squared is going to be 2/3 x cubed. And your bounds of integration are running from 2 to 4. Plug your upper limit of integration in. So you get a half of, when you plug in, you'll get 4 to the 4th divided by 4 is just 4 cubed. But 4 cubed is 64. So we get 64 plus 2/3 of 4 cubed is just a 64. So 2/3 of 64. Minus, plug in your lower bounds of integration. 2 to the 4th power is 16 divided by 4 is 4. Plus 2 cubed, it times 2 is going to be 2 to the 4th, which is just going to be a 16 over 3. And then close the parentheses. And now it's just a matter of walking this through and simplifying everything down as much as you can. So I'll go dot, 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 because at this point it's just a little bit more arithmetic.